Many of you who's been working with GHDL and LDC and so on know about GPK Wave. But it's been out for quite some time, maybe not being updated very frequently. So this is something completely new.
Thank you. Is it working?
Yeah.
I will also talk a bit about VUnit, but you're correct, it's basically a Surfer introduction. But yeah, let's keep it from the VUnit perspective anyway. So one of the benefits with VUnit is you can easily use it to run all your tests, either as part of continuous integration on one of these CVS or CI environments, or you have some powerful simulation machine that you can run things on. In many of these situations, people tend to use EHL or NVC, or you just really don't want to pay the license cost for anything else. But it's still quite common that CI is executed using EHL or NVC because it's free or open source. And if you want to store the waveform file for later debugging, we could do that. The problem that we sort of try to solve here or discuss solutions for is maybe not a huge problem, but still it's a bit inconvenient sometimes to get big files. You could of course just use SCP, that's not the problem, but it's maybe a bit tedious. Also your local computer that wants to check things might have limited memories and so on. So I mean, yeah, not a major problem, but still one could maybe solve it a bit better. And that is where Surfer partly come in. So that's a rather new open source waveform viewer released under UPL. This is about 1 year now. It's written in Rust using eGUI for those interested. So it doesn't dub cores, it's panics. I think that's the sort of main thing with Rust. It runs on, well, the fact that it's written using Rust and eGUI makes it run on Linux, Windows, Mac OS, also in the browser, so you can run it in your phone if you want to. It doesn't have a perfect interface in the phone, but you could zoom and pan and so on. It also has a VS Code plane, so yeah, you could configure it. So if you double-click a VSD file, for example, it opens in VS Code. It's designed to be highly configurable. Could configure lots of things, maybe not all, but the idea is that we take very few, or the most common design decision we take is make it configurable. We could design something or decide. It also has both a keyboard and a mouse-driven interface. So those of you who are used to like typing commands will be happy, and those of you who use mouse gestures will be happy. Because we are multiple developers with multiple preferences. So this is primarily developed in my group. It was my PhD student that started this because he needed a waveform viewer, or needed to have a waveform viewer with specific features. But GTK Wave was a bit, it has like a few thousand global variables that controls everything. So it was pretty hard to configure out how to do what we needed. So we decided to write its own, and then we have got support from primarily Hans Kepler University in Linz, and also a now PhD from UC Berkeley handles the waveform reading and so on. One of the main features is that we have what we call translators, which basically turns the bit vectors into something more readable, and that was actually the purpose, because he has his own HDL, Spade, that has some fancy data types, but then everything compiles to Verilog, and then Verilog is simulated, and you lose all type information. So that was sort of the purpose. We wanted to restore our structs and our tuples and so on from these bit vectors. And then me working in arithmetic, I added things for all floating point formats you could figure out, POSIT number systems just for fun, and so on. So we have quite a lot of, you could turn your bit vector into anything, including RISC-V instructions. So you could easily disassemble your RISC-V instructions and also other instruction formats. So that's one of the big things. We will currently working on a sort of Python support for this as well, so you can write your own configure your bit vector output, whatever you want to see here. So that's one selling point We currently support these file formats, so both the sort of standard waveform formats, VCD, FST, which is the GTK wave format, and GHW, which is the GHDL format. We also now have support for memory transaction, so FTR is an open source memory transaction format, so you could simulate that as well and view it here. If you do more high-level simulations. CXX RTL, how familiar that is, but uses the open source synthesis tool as its own simulator called CXX RTL. And that we also have support for that, so we could run interactive simulations using that, since CXX RTL supports that. We have discussions with GHDL if we could possibly run interactively with GHDL as well. And then maybe it's also a bit more interesting, not from sort of main perspective on this talk, but yeah, it's good to know. So I've discussed with Tristan now if that's the way to go, or if we at least somehow could get interactive simulations. So we don't need to first run the simulation and then look at the waveform file. One thing to know is that this is under active development, so even though we have quite a lot of neat features, we're also missing quite a lot of features. Sort of main feature is grouping of signals. That's, I think it was 2 days ago someone said add that and I will switch. And yeah, that's not the first comment on that slide. So that's high priority, but also requires a bit of rewrite. We release this every now and then, but it's still recommended to run the bleeding edge. Fortunately, on the website, you can just download the latest version from Git, basically. So yeah. 2 features that we haven't mentioned, but are the ones of interest here, is that we can open the URL directly. We don't need to download the file, which maybe solves part of the problem. And we also have a server mode, so we'll talk a bit more about those. But yeah, if you now run GTK Wave and would like to try something else, this might be an option. You could actually click this link. Let's see, I will fully prepare this. Oh yeah, sorry about that. Let me just get the file sharing on because I will need that later. So let's go back. So first, since this is VUnit, some related features added for VUnit 5. Talked about parallel running now. Now we can set this number of parallel threads to 0 and it will run with whatever your machine supports. So that could be quite convenient if you jump around different machines, just want to maximize it. So minor thing, but still, yeah, relevant. Since now not only GTK Wave exists, there's also a viewer argument. So yeah, you could set which viewer you want. So if there are more viewers than these 2, you could use that. If you don't provide it, you will first try if GTK Wave is available, so it works just as before. So if you have GTK Wave. And if you don't have GTK Wave but you have Surfer, it will start Surfer. This also means that all these GTK Wave arguments are renamed to viewer. Makes more sense. If we warn you about it. I still think it works using the old ones. There is, or at least there will be, an additional argument here, waves, to generate waveforms without starting the graphical interface. So for example, if you want to run it on CI. It works now. If you specify GTK wave format, it will generate the waveform output. If you run GHDL, not with NDC. So yeah, it is documented, but maybe it wasn't obvious to me that happened at least. And also, if you have run this with tried both GHDL and NDC, there's been some differences. For example, GTK wave format would generate a wave file with GHDL, but not with NDC. Now both works the same way for these things. So it's a bit more unified. So it doesn't really matter if you run GHDL or NDC. It should be hopefully on par in terms of features. So that was sort of the VUnit specific thing. But yeah, I guess at least many of you from the industry, and maybe you don't post your projects on GitHub, but there is also a sort of open source community that does run it on GitHub. And of course it's run GitHub in closed shape. Either way, you could just download your artifacts pretty easily from GitHub. There is a link. The problem is that you need to be logged in, so you can't download this link from Surfer because you're not logged in from Surfer. And you have a zip file, so that's not really convenient. And of course, both could be solved in Surfer, but they are not solved yet, at least. Part, what hopefully will show up, is a float-generated web page with waveforms. And now, if I got the internet to work, yeah, this is what it hopefully not will look like, but what it looks like right now. So you could easily get your waveform, or you can actually start here. That's the problem now. Start with computers. Reload. Yeah, you can just get it directly. It's not very exciting design, but I mean the concept works. So if you run an open source project or like easy access to waveforms, you can do it something like this. Either download it and so on. Not a big help, but something. The idea is to integrate this with GitHub Actions, so it should be easy. Just like, okay, generate a web page once you're done simulating things option. So you could integrate this easily into the design flow. It will of course be brilliant if this just didn't work on the main branch, but also in pull requests. So you could see what actually happened in pull requests if you work that way. I know, you might not say graphic design is not really. I've done HTML in the late 90s, so there are lots of new things that I don't really know about, and maybe don't have the talents to do either, so it's not fixed. And of course, it would be nice if this works with GitLab as well, so that's also an idea to set up a similar environment. So previous is more proof of concept that it is doable, and there are some things working on that. The maybe more interesting part is the Surfer server called Server, and it was sort of community driven. People didn't really want to copy their huge waveform files using SCP. Especially if they have a small computer. Now it's not actually this bad because the Berkeley guy that does the waveform backend is pretty smart. So he just loads whatever you need. So you don't really need 20 gigs to load a 20 gig file. But still, the problem is still there. You would probably load lots of information that you don't need. So we have a sort of client-server approach. You can start a server version on a machine that has the waveform file. So typically, if you have local disk on that machine and you have huge waveform files, you start the server there, and then you connect Surfer using open URL to that machine, and everything works as fine. And it will only transmit not now the whole file, but only the data that you request. So it's much faster compared to SCP things and so on. And one could also imagine that one runs all this in a sort of higher cloud instance, and then post this up afterwards and so on. Still some things to do here. Multi-file support, for example. So if you run a complete VUnit test suite, maybe you don't want to start a server for one file, but for all files. Sort of works, but not good enough. It looks like it works, but it actually doesn't. If you try it, there is a merge request. It reads the wrong data for some reason. But yeah, it looks like it works. And yeah, maybe considering this should be all reconfigurable and so on, we should do a bit of effort to make it more configurable. So this is one what we call experimental feature. It sort of works, but yeah. So typically, it would look like this. You start server with a specific file. It tells you that, okay, either set up an SSH tunnel and access that, or if your machine is not behind some firewalls, you can possibly access it. And that's it. Rather than pointing to a PCB file or something, you just point to this, and it works transparently. So there are some new features in VUnit that basically simplifies running things remotely, and also then checking the waveforms locally. For example, if you want to do continuous integration or has a simulation machine that doesn't share disks and so on. It also supports different waveform viewers. Surfer is then sort of motivation for that. Surfer will directly read waveform files, so it simplifies it a bit, even though it doesn't really, well, doesn't fundamentally help, but it makes it simpler. But this server can then serve the waveform file remotely, which then helps a bit more at least. So some new features and some advertisement for Surfer. And I don't know how many of you use open source EDA tools, but if you do, then you might be, or I would be interested in collaborate at least, or we could collaborate, could be thesis projects. We might be interested in hosting PhD students that you might need to get the edition in our hands for a few months for free. And of course, all the usual academic stuff, we could apply for projects and so on. So just opening up for that, so we have decent knowledge in the area. I also like to point out another tool that might be of interest that we're developing, API types, which is basically NumPy, Python array library, but with fully configurable data types. So if you need a 11-bit floating point format or a 17-bit floating point format with stochastic rounding, that could do that. And it works more or less like NumPy. There is a release in the next few days, so it would be better if you try it towards the end of the week than right now and get a few more features. And to help people now trying to remember these things, there are some QR codes for these things. It's made HDL, by the way, since I guess we have a bit of time. If you like Rust and want to do write hardware in something that isn't Rust but has some similar features to Rust, that does automatic pipelining of things in the sense that it's still HDL, but we don't need to copy signals and so on. You can access a signal from a previous pipeline stage by just getting the name. It has fancy data types, some type things, so option types and nonce and so on. That automatically is used for clock gating. So it has some interesting features. And also, yeah, some people are using it. Questions? Yes?
One question here about the integration with GitHub.
Yeah.
GitHub output was great, but can you, in your way of providing the API for that, can you provide the API in a way for different pipelines to generate this kind of stuff, not only for GitHub and GitLab?
The output is a rather primitive Python script, so yes, you could use that on anything. So I mean, it's more these deployment things that would be. So basically, there are two things. One is to sort of do all the processing, extracting waveform files generate HTML, and that's Python, basically. And the other part is then how do we deploy this so we get it on a GitHub IO or GitLab pages or something. And that's, yeah, that's really what's maybe not missing, but should be done in a better, more flexible way.
But the Python part is already accessible.
Yeah, if you know where to look. But I mean, send me an email. I'd be happy to share it, but it's like a very primitive Python script. Yeah.
Thank you.
I have a question.
Yes.
So it's more a higher level question. So how much do you take into account your compliance to request from the functional safety industry, for example? So you see a lot of new frameworks and VUnit and stuff, but it's a lot of big part of the industry is functional safety, and this is very conservative. And you need to follow their formats, the processes, and so on. How does this comply to this?
I can answer for VUnit, I guess.
Yeah, and that's probably the only answer you will not get, actually, because it's not something that we have considered, because, I mean, basically, well, I use VUnit in my projects, and then I build Surfer, and then I thought that, okay, we could simplify things a bit between those, compliance didn't really come to my mind, to be honest, and I don't really work with function safety. So yeah, I think Lars' answer is the
Yeah, so when it comes to functional safety, I mean, VUnit has been used in projects for primarily maybe automotive safety. So then there is a process looking at everything you do in the organization, tools included, and you have to qualify tools to be sort of okay to use. And there are numerous ways of doing that, so it's not like, okay, I can do a sort of compliance thing and just hand a paper saying that VUnit is compliant with ISO 62602 or whatever. But it has been through that process and passed. So also in the military industry, there are various standards that VUnit has been through. And probably in other areas that I'm not aware of. But for sure, it's possible and has been done.
It could be interesting to see if Surfer, I don't really know what it would be. Is it like it doesn't miss the more transactions, or it's hard to say, because sometimes it does miss well, weird input might get weird output sometimes. So I'm not saying that it's like completely bug free, but I don't really know if models in is that compliant. I guess DTK way would be the main concept.
Yeah, sometimes also the solution to all this is that you use, for example, if you cannot make commercially day tool compliant, you can use two of them and see that they both come to the same conclusion when it comes to application. So that's one thing of working around tools that you cannot sort of make compliant in isolation. You have to use redundancy. It is used as a military, automotive safety. Before summer, I had the opportunity to sit down with the FPGA community at NASA. So we have things orbiting the Earth that was developed using VUnit. So it can be done, but there is no sort of single answer to how it's done. It depends on the different applications, basically.
And I think VCD files, there are quite a lot of ad hoc extensions to the VCD format. Different tools just adds things a bit arbitrarily. We have got quite a few bug reports that some tool generated VCD file that wasn't at all compliant with the Verilog standard, but yeah, they thought it was a good extension. So.
I can also say some words about the relation with VUnit. I find it's very interesting. One thing you mentioned that you say, oh, it's not so interesting for us, but I think it's very interesting for all of us, is that you can do, hopefully in the future, interactive debugging in waveform viewer with GHDL, so the open source simulators, rather than just running for an hour and then getting ECD file. The other thing is also everything with the publish on VUnit is tested. You have the test benches, and as Thiago mentioned, people are looking at the tests to figure out how things work, how are they intended to be used. But if we can also add waveforms to that, that's going to give another way of looking at things and help people use the different features that they have. Another thing you also mentioned is that the original intent was that when you spade and transform it into Verilog, you lose all the type information and you sort of recover that. And that's kind of the same thing that happens when you do message passing with VUnit and communicate with verification commands. Because we build that on a software style of message passing, which VHDL cannot handle. We have to work around the typing in VHDL, which means the same thing. Typing information is lost when it gets to a simulator. So using the configurability of this tool would enable us to visualize transactions made in VUnit. So that would also be a use case.
And as it said on the slide, I didn't mention it, Sesson might be the sort of most well-known alternative HDL. And there are some guys that has built a preprocessor, so one could use Surfer for Sesson as well. Unfortunately, it's not integrated into Surfer yet, but we hope that it will be. Because the idea is that it should be easy. So records in VHDL, for example, GTK Wave doesn't support those. We plan to at least. Maybe they also plan to, but yeah. So we'll see in a few months, or next year, or in 2 years.
Great, thank you.